All right, so I just wanted to show that short clip again because when we're thinking about the different transformations in math, that moving a figure, like all the things that actually have to go into that. And so what I want you to do is real quick, I want you to generate a list at your table with the people around you of what are all the ways mathematically we can move a figure. All right. So you've been learning a lot about transformations. I want you to think and generate a list. What are all the ways you can move a figure mathematically? Okay? Come up with your list. You can put it anywhere. So what are some ways you can move a figure mathematically?
Rotate it 90 degrees.
So you can rotate. Okay. What else?
Translation.
What's a translation? What does that mean?
Like any figure that moves one point to another.
How does it move though?
Getting flipped.
So we got rotation, and you said translation, but I want you to be able to describe what that means, okay? So talk with your group, okay? So what do you guys got so far?
Translation, rotation, reflection, dilation.
Okay. What does a translation do?
Just like you move it, like to left,
Like
right or left.
this, just move it right there.
Okay.
Yeah.
And then reflection?
That's like this, but then you like flip it over.
Yeah, you
Yeah.
flip it to the other
Okay,
side.
so that's two.
You can flip
What
it
are
over
some others?
with a Y,
Rotation would be like just rotate.
around.
Okay, very cool.
And dilation, I forgot.
I forgot what that was.
Okay. But you know it is a way we can,
Yeah.
Yeah.
okay. All right. So what we got here? What are ways we can move a figure? So those are all the key, definitely the words. Now, what does it mean to translate something? Side to side? Can it go up and down? Are you sure? You think? So you can only go up and down and left and right? Could I take, this was the coordinate grid, could I take this and move it this way like that? Would that be a translation? Why?
Because it's still being the same, it's just...
What's the actual action? Like if you had to put a word to it, what action happens in a translation? Slides. So you can slide anywhere, right? Does that change the actual shape?
No.
No. All right, what about, you said something else. What was the other one? You rattled them all off. Reflect. So describe that. Okay. So you like physically picked it up and flipped it over. All right. Awesome. All right, make sure you guys have all those down. Things that he just said, okay? So what was the first thing he said?
Rotate it.
Okay. So why do you want to rotate it?
So it's facing the same direction.
All right, it's not facing the same way, so we could rotate it, okay? Then what do you want to do?
Translate it down and then to the right.
Okay. And is that going to make it go right on top of it? So if we turn this thing around, move it down, and then over, is it going to be right on top of it?
It's going to be in it, but then you have to dilate it so it's like the same size.
So we have to dilate it too, okay? So that seems like a lot of work. Can you do all that?
I don't know.
Is there anything? You can do it. Mathematically, all that sound. I was just curious. There's a different route.
Reflected?
What would reflecting it do?
Because they're not the same size.
It would automatically go.
Here, let me grab something real quick. All right. Here. So what I want you to do is I want you to copy that image right here, the A, B, C, D. Go ahead and, yeah, just trace it real quick. It doesn't have to be perfect. Don't worry about it being perfect. Okay. Then if we reflect, what we say we needed to have for reflection? We had to reflect over what?
The y-axis?
It's not always,
no, X.
it's not always an axis. Doesn't have to be, but a line. Okay. It could be. So let's trace the x-axis then. Okay. If that's what you want to do, go ahead and trace the x-axis.
So then draw that circle.
All right, so if we reflect, like, how can we like physically reflect it using the paper? Like, what would that look like?
You like just draw another one right here, right?
So what'd you do? You flip it. A reflection's a flip, right, over the axis. So show your table what you did again. That was really cool. So you took it, and it's so figure's going to be. So now you got it there. Now how do you get it completely to cover that other shape? Okay?
You dilate this down.
So now we need to dilate. So I'm going to leave you alone. I'm going to come back and check in on you probably in a couple minutes, okay? See if you guys can figure it out. About that. Start somewhere, right? And that's okay if you're not sure quite what to do yet, but we need to figure out where you're at. So tell me what you know about this so far.
Trapezoids are both right there.
2 trapezoids, all right? And so are they the same size?
No.
No. So if they're not the same size, we're going to have to use something to make them the same size, right?
You shrink it?
So a dilation, okay? A dilation makes things bigger or smaller. We talked about that, right? So we definitely know a dilation's a part of this, okay? What else do we need to do, like, to make this match up to that?
Flip it. Like, once you make it small, you gotta flip it. Right? No.
So you're trying to get this one over here, which is fine. Our goal was to get that over here. So you're working kind of backwards, but
So you make this one bigger and then you flip it.
mathematically, how do we do that? And you're like, tell me, I don't know what we're doing. Like, that was beautiful. Now, how mathematically do you do exactly what you said?
I don't know. I have no idea. Do you take the measurements, right, of that already here, and like go 2 units to the right?
Okay, so DC is 2 units, and this D prime, C prime is 1, 2, 3, 4 units.
So you do
So-
go 2 units to the right.
So is that how we dilate something? Are we moving it to the right?
No, it's not right either.
What's the measurement of AB? How long is AB? And how long is A prime, B prime? How long is A prime, B prime?
8 units. It's like, this is like 2 times bigger than that. You can fit 2 of these in this.
So this is 2 times bigger, so how do we, so you're saying this is 2 times bigger than this? So how do we make it 2 times bigger?
I don't know. Copy the things, copy the measurements, and just make it bigger.
By how much?
2 times.
2 times. Do it. So this DC, make it 2 times bigger right now.
Okay. So then now do I just make this right here? Right, yeah. And now do I just draw it?
Will it look like that?
Not yet. No.
Not yet, but you're a lot closer, right? So go ahead and draw it. Draw your new shape. What does it look like?
Now it should look like it, right? No, it doesn't.
Keep working. You're so close, okay?
Got it. Wait, I'm pretty sure. Yeah. Yes, I do.
So slow down a second and talk with me again, okay? So you moved, it was 1, 2, 3, 4. I get that. Because you're trying to make it the same as that one. I get it.
Now it's done. That's right. It should be. I hope.
And so this one, I think's there. And then it has to be 1, 2, 3, 4, 5, 6, 7. Keep thinking, okay? You're really close. So you told me, again, what are we supposed to do mathematically?
Make this one bigger.
Which is mathematically what?
Dilation.
Dilation. Okay. Put it on the coordinate
Mark
plane.
the points.
Okay. So then how are we gonna? Again, the goal is to get this shape to here.
Okay.
How do we do that?
Flip it, which is reflect it over the X.
Okay.
Yeah.
So we need to reflect it over the x-axis.
But this is also what's it called? This is dilated too.
Okay. So there's two things we need to do. Can we do that? Can you grab your paper? So how do we do that?
Basically, we have to apply these over here. Basically, reflect it over here, and then you would draw all the dots, and then you would dilate it down.
So you want to take
Actually,
this
you
and
have
flip, reflect.
Reflect it, yeah.
Awesome. Let's do that first. Let's start there. Let's not try to do it all in our head at once, okay? So let's try to reflect that over here and see where you can come up with, okay?